this video, I'm going to show you what is the z-score and how we are going to use it. Now, let's, for our example, say that we are interested in IQ scores, and we want to know that what proportion of the population that have a normal distribution with the mean of 100 for the IQ score and standard deviation sigma of 15. What proportion of these people have got an IQ score greater than 120? All right? This is a typical question you might get for the z-score. Now, this population of individuals which are normally distributed with a mean of 100 and standard deviation of 15 can be represented on a bell-shaped curve with the mean of 100 and sigma of 15. All right? Now, the first step is we have to transform these raw scores to the z-scores. But just to show you that graphically that 120, let's say if 120 is in here, then we really want the probability of x greater than 120. So we want this area under the curve. All right? So we change it to a z-score. Now, this z-score, we know that z-scores have got a mean of 0 and the standard deviation for the z-score is equal sigma is equal to 1. Now, to transform the 120 to a z-score, we need the formula to transform it. So we know that z is equal to the observed value of x minus the population mean divided by the standard deviation of sigma. All right? Now, this x observed value is really my observed value. We want what proportion is greater than or less than this value. So, probability of x greater than 120, we can change it to probability of z greater than what value? So we have to use this formula. So we say that here it's equal to x observed value is 120 minus 100 divided by sigma, which is 15. All right? So this is equal to 1.33. So probability of z greater than 1.33, we have to calculate it from the tables. So how can we show it on our z table? It would be probability of x greater than 120 is the same as probability z greater than 1.33. So we want this area under the curve that we should use either ESCI or the tables, statistical tables, to calculate this value. As you can see in the table, 1.33 z-score in table A1, the probability of z greater than 1.33 is 9.18%. So it is 0.0918. So we can say to calculate the probability, if x has come from a normal distribution with a mean of 100 and a standard deviation of 15, the probability of observing an individual with an IQ score of 120 or more would be the same as, so observing a z-score of 1.33 or greater, which is equal to 0.0918. Therefore, in this population, we can say 9.18% of the individuals have an IQ score greater than 120, or in the other words, the probability of observing an individual with an IQ score of 120 from this population is 0.918.